All right, so welcome everyone, and good morning, good afternoon, good evening, wherever you're joining us from. Either you're joining us via YouTube, via Twitch, or via LinkedIn. Welcome once again to the last class for cloud computing. Welcome everyone. So please, for every one of us that is currently here, either you're joining from YouTube, Twitch, or LinkedIn, please do well to drop a message on our Discord room so we'll have more persons joining us because our instructor is already here, William Moko. Sorry, let me just say Mr. Williams. Sorry about the pronunciation. He's a cloud engineer
Oh,
and
it's
is
fine.
going to be taking us. He's going to be taking us on the last class for this cohort, and he's going to be taking us on cloud engineering training recap. Yeah, so welcome once again, William, and thank you so much for being here.
Thank you so much, Emanuela. I really appreciate the opportunity to just be around and share my knowledge with everyone. I'm William Koyani, if you've never met me before. I'm an AWS technical instructor with Get GIBT as well as an AWS authorized instructor, and it's a pleasure being around. So great seeing you around. Hoping to have an interactive session with everyone. So you can ask the questions that you want on the chat. I'll be able to see them and make it interactive as possible. That's all. Okay. Um, Manuel, I hope I can begin the session. She's around. Okay. So today,
Sure, you can. You can start.
okay, fine, great. So it's cloud engineering recap session, and it's more of like a summary. You've already covered an introduction to AWS. You got introduced to cloud computing, storage, and database services. Essentially, everything that you need to be a cloud engineer. So I'll just do a quick recap, and then we can ask questions in between. I'll run you through some bit of demos. If you have no idea of AWS, then you'll get a hang of everything else. So let me start. Um, so I love this comic. It's a comic, and the reason as to why I started with Python, it's because as a cloud engineer, essentially you have to know some bit of programming, and the programming language that you really have to use is most is Python when it comes to AWS. You realize you'll have to write some bit of Lambda functions, and Python has to be incorporated there. So with this comic, it's more of a guy asking someone else, "You're flying," and is wondering, "How are you flying? How are you able to fly?" So the guy says it's Python, and the comic is a bit funny with how it goes on. He says he learned Python last night. Everything was simple. It was just hello world, and he does not know dynamic typing, the friend. So it starts with, "Come join us in programming. It's fun again. It's a whole new world up here. But how are you flying?" So he keeps asking, "How are you flying?" And if you can see, it continues with an interesting story. Just typed import anti-gravity. So you realize with Python, you have to basically use some bit of import functions to be able to do some things when it comes to it. So that's it. So how it ends, it's a bit funny because it says, "I also sampled everything in the medicine cabinet and for comparison, but I think it's the Python." So the reason as to why I started with Python, why do you need Python in the first place as a cloud engineer? You have to have an understanding of some bit of programming, because you have to be writing some bit of Python scripts and some functions when it comes to Python. So that's why you really need to have Python as one of your skill sets as a cloud engineer. I saw there was a lesson that you introduced into Python and how to basically work with Python. So that's why you really need Python to have an understanding. The other thing is Linux is also another scripting language that you can also use. And why Linux? And we have a couple of we have still another discussion. It's more of a boy asking the dad, what's the cloud made of essentially? And the dad says, mostly it's Linux servers. So you'll be finding yourself having to deploy virtual servers on the AWS cloud. That's why you've realized that the cloud is essentially made of Linux servers mostly. That's why you have to have an understanding of Linux. And the reason as to why you also have to have an understanding of Linux, you have to basically get a hang of the basic functions that you have to run, commands that you have to run when it comes to AWS Cloud. So we'll be running some bit of commands on the AWS Cloud and just seeing how you're able to interact with the Linux system. So an intro into the AWS Cloud. So what is AWS Cloud? It's the on-demand delivery of IT infrastructures or resources and application over the internet. So with the pay-as-you-go pricing. So that's essentially what you get with the AWS Cloud. There are no upfront investments that you have to make. The upfront investments, it's essentially like having to get servers, having to invest in a data center. You don't have to do that. So all that is catered by AWS because they have they have invested a lot with the data centers. That's why you realize that there's no upfront cost you have to invest in. Provisioning of your cloud resources as needed. It's just a click away. You click and go, and you are able to start up a virtual server and just be able to use it. The mod, it's basically pay only for what you use. You don't have to worry about anything that you're not using. Let's say if you're using a cloud resource, like say like an EC2 instance, we'll be discussing on EC2 instance in the upcoming modules just to see how it looks like. You pay for only the capacity that you use and the resources and the time that you use it. So that's why you realize pay for only what you use. That's this main thing when it comes to AWS Cloud. So we have said it, the on-demand delivery of IT infrastructures over the internet with a pay-as-you-go pricing, no upfront cost. With the no upfront cost, you're actually trading capital expense to variable expense. We'll also be checking it on the upcoming slides. Just took some time to come up with slides. I hope they'll get the conversation that you're going to have for today's session. We'll be doing some bit of demos just to reinforce the concepts that we learned for today. Thank you everyone that is putting some comments on the chat. Good evening, good evening. I like it. So we can continue. So with the cloud computing concepts, the main things that you have to have an idea of, it's we have to start with servers. Servers are the main things you have to understand. What is a server? What's a server used for essentially? Then we come into storage. Some of the concepts that you have to understand in storage. What are the storage devices that are there? Services that are there in the AWS cloud, databases. You have to have an understanding of databases to also just use databases. And we have a variety of other services that you can also make use of in the AWS cloud. And in this case, you might have to think of other than the servers, the storage, and the databases, you have also machine learning. Anyone who is into machine learning, I'll just type it as machine learning. If you're into IoT, so we also have IoT devices that or services that you can make use of on the AWS cloud, and a variety of other services that you can also utilize on the AWS cloud just to be able to know how to use them. So we'll be discussing them regarding the servers, the storage, the databases. We'll also check some of other services that are essentially there that you really need to take a keynote of. Just before I continue with the deployment models that are there, you're going into the AWS cloud as a cloud engineer. There are some things you have to capture first. And as a cloud engineer, your work is essentially to design, implement, and also maintain the cloud infrastructure of probably your organization. And as an architect, let's say since you are an architect on AWS, as an architect, there are some things you have to, I think architect is written that way, I'm not so sure. So as an architect, there are some things you have to capture first when you're dealing with the AWS cloud. And the main thing I want to focus on is the AWS well-architected, well-architected framework. I think we just uh, so with the AWS well-architected framework, it has five pillars, and the five pillars mainly you realize will get operational excellence as a pillar, security as a pillar, reliability as a pillar, sustainability also as a pillar, cost optimization is also a pillar that you can also make use of on the AWS cloud, and performance efficiency is also another pillar that you can also make on the AWS cloud. So as a cloud engineer, you really need to have an understanding of designing well architected architectures that are there, and the solutions that you'll be coming up with in the AWS cloud, focusing on the well architected framework. I've said mainly we have five pillars. So with the five pillars, whenever you're coming up with architectures, ensure they are centered around the five pillars. And I've said we have security as one of the pillar. So we have security, reliability, and security is just ensuring that you focus on protecting information and systems on the AWS cloud. Reliability, it's just the ability for your system to recover from failure and being highly available. Then the other one is operational excellence. So I just write with an X, operational excellence, and this focuses on running and monitoring systems continuously. Um, we have the other pillar, which is sustainability. I guess sustainability was introduced recently. Sustainability. So sustainability was introduced recently, and this one is basically focuses on minimizing the environmental impact of running cloud workloads. And if you think of sustainability, it's more of trying to reduce the carbon footprint with running cloud workloads. The last one, I think, how many are these? There are four. So we have the last one, which is cost optimization. Uh, so with cost optimization, if you're trying to think of cost optimization, a lot of companies they have this buzzword, which is cloud, cloud, cloud everywhere. And most companies are trying to migrate into the AWS cloud. And if they are migrating into the AWS cloud, or even the cloud infrastructures that are there like Azure, GCP, they are mainly focusing on cost optimization. So cost optimization is something else you have to focus on. And this one, it's mainly avoiding incurring costs, unnecessary costs. And you can remember at the introduction, I made an introduction of basically how you're able to save on cost on it when you're going into the cloud. So we have deployment models. We have cloud, which is one, and this one focuses mainly on running all your workloads on the AWS cloud, or even the cloud infrastructure that you choose to use. Then we have the hybrid. I know you've been introduced to basically this with the cloud computing concept. We have hybrid. So hybrid integrates cloud and the on-prem infrastructure. If you can see here, we have like a bit of an architecture here. This is probably your on-prem center. Uh, or your on-prem data center that you have. So if you're thinking of a hybrid architecture, it's basically integrating high cloud and the on-prem infrastructure that you have provided. Cases you might find yourself running a hybrid cloud, it's probably, let's say you have like some bit of compliance issues that you have to maintain, some workloads running on the on-premise data centers that you're running, and others on the cloud infrastructure that you selected. Then you have on-premise. With on-premise, basically it's maintaining more of a private cloud. They say with on-premise it's private cloud since you're the one who's maintaining it yourself and you don't share it with anyone. And if you think of on-premise, it's more of the data centers that your organization is running as a company. So these are the deployment models. We have cloud, and cloud is essentially running all your services in the AWS cloud, and it's more. This one is public, and then this one is hybrid, just integrating the public cloud and the on-premise data centers, and then on-premise is more of a private one that you're maintaining yourself. If you think of on-premise, you have to worry about purchasing the servers, maintaining the security of your on-premise data centers, and the cooling systems that you're supposed to think of purchasing there. So there's a lot of cost that goes into maintaining an on-prem or a private cloud yourself, which is the on-premise data centers that you have. The other thing, benefits of running into AWS Cloud, and with the benefits, we'll basically start with, probably you're wondering why businesses are moving to cloud mainly, and it's to make use of these benefits: agility, elasticity. We'll just be discussing on them, cost savings, and rapid deployments. So if you think of agility, it's the ability to basically innovate faster without the need of managing any infrastructures that are there. So it's more of transforming the customer experience. So when you think of agility, it's more of innovating faster and transforming the customer experience. So these are the benefits. Then we have elasticity. Uh, with elasticity, I know you've covered on elasticity when you're introduced to cloud computing. So elasticity is more of being able to scale up and down to cater for the demand of your application. So that's when you think of elasticity. You might find your application is experiencing high traffics, and you want to be able to scale up and down just to cater for the traffic that your application is experiencing. And the best example I like explaining when it comes to elasticity, I don't know who has heard of, is it Black Friday or Black November, when it comes to shopping on e-commerce platforms like Jumia, I don't know, like Amazon. So there's that month where they always have like a flash sale, and during that month you realize that they experience high traffics on their application. So for them to be able to cater for the high demands on their application, it's basically being able to scale up and down, or scale out basically in and outwards, basically to cater for the growing demand. And we have scaling up, um, and scaling down. So the difference when you're trying to get between scaling up and scaling down, with scaling up, it's more of improving the power of a given application that you're using. Let's say if it's an EC2 instance, you move to a larger one, and if you're scaling down, you move to probably from a T3 micro to a T2 3 micro to a T2 micro. So that's why we think of scaling up and down. Then cost saving, and with cost saving, you're able to trade on. They say you're able to trade on capex, uh, capital expenditure, uh, for variable for variable expenditure. So with the capital expenditure, you don't have to spend a lot on coming up with a data center, buying the servers, maintaining the security of your data center, the security appliances that you have to get within your data center. That is probably the cameras that you have to install within your data center, the cooling devices that you have to install within your data center. So you trade all that of coming up with a data center, and just go with the variable expense. And with the variable expense, basically paying for what you use, the resources that you consume on the AWS cloud. So that is one of the benefits. Then the ability to deploy, rapidly deploy your infrastructure. We'll be basically seeing with a demo of how you can quickly deploy a virtual server on the AWS Cloud within just a few clicks, and you already have a web server running on an EC2 instance. So rapid deployment is also another feature that you get to enjoy as you're having to go to the AWS Cloud. So we'll go into last Friday of November. Thank you so much, Naoko. Yeah, it's during that time when guys are shopping a lot. I know people. There are guys who really save up into November, and then they start buying in bulk during that time. So you can imagine you have an application. It's an e-commerce platform, and it's experiencing like a high traffics in the application, and you have not integrated. Probably we'll be discussing other concepts of how to scale it into your applications and how you're able to scale your applications to cater for the high demands that you're experiencing. So thank you so much, K Fox. I think I got your name right. Yeah. So an overview of the AWS services. So we'll be discussing just an overview of the services that you have to take a keynote of before we jump into some demos. The first one is IAM, and in full, it's always abbreviated as Identity and Access Management. And the reason as to why it's the first service you have to start with is that in AWS, they consider security uh, to be job zero. So I don't know if someone can just comment on the chat what it means by being job zero. Uh, as security being job zero, this mainly means it's a top priority. It's the first thing they really consider when it comes to security. And in terms of security, there's something else we have to also take a key note is that we have the shared responsibility. I think it's written that one, just abbreviate it that way. The shared responsibility model, where we have security of the cloud, uh, security, let me just abbreviate it, security of cloud, and we have the security in the cloud. Uh, I think the shared responsibility model. With the shared responsibility model, we have the security of the cloud, which is solely the responsibility of AWS. They're the ones who have to worry about the data centers that they have and how they have to maintain the security of those data centers, installing the security appliances that are required. Then when it comes to security in the cloud, it's essentially you as a customer who is using the AWS infrastructure. You have to maintain security for your resources or even the accounts that you're using. That's why we start with the IAM service, which is the identity and access management. And mainly what it does, it controls access to your resources and services. And if you're new to AWS, you have to create an account. And if once you've created an account, you'll have to go to an IAM service and be able to create an IAM user and some groups and just assign some bit of permissions. We'll go into the management console, and I'll just show you a bit of a demo of how to basically create a user and assign some bit of permissions and put them into groups. So IAM, what it does, it creates, you're able to create and manage users, and users are basically either a person or even a given service that is using the AWS cloud. Groups are basically a collections of IAM users, the ones that you get. You also have to enable multi-factor authentication for even greater security. And with multi-factor authentication, I want to basically give you an example of probably how you have your phone. With your phone, you've enabled probably a password security or even a fingerprint. I know people have enabled like a password and a fingerprint, and that's like an extra layer of security to your device. So when you're going into the AWS cloud, whenever you're creating your accounts, you have to enable a multi-factor authentication. And this is actually a 2FA, two-factor authentication. Other than your password, what else can identify that you're the owner of that account? So there always are other MFA devices that you can use, like a Google Authenticator, or even I think there's the Microsoft Authenticator. It's also another MFA devices that you can also use just to get that extra layer of security to your account in the event, let's say, your password is compromised. For someone to be able to access your account, they have to have the MFA device for them to be able to access it. But if they don't have, your account is still secure. So identity and access management is one of the services that you have to focus on when you're going to AWS Cloud, and ensuring you have that security for your resources on the AWS Cloud. So let me just go to the so I'm on the AWS management console. So let me expand it so I can see. Great. So it's under security, and you can see the services that are here, all of them. So under security and identity, this is where you get IAM. Under the services, just you scroll down and go to security and identity compliance. Security and identity, you have AWS Artifact, Audit, Certificate Manager, Cognito, Detective. You can take some time and just go through exploring all these services. And there are different use cases like guard duty, identity center, Amazon inspector, Messi. There are a lot of services when it comes to security, identity, and compliance. But for today's session, we'll just focus on IAM, which is the main seat from the server, and you're able to get it. So it's taking some time. If you can see MFA, so MFA, they are really crucial to have within your account. So in the event your account is compromised, someone has to get your MFA device for them to access your account. So on the left pane, you can see we have user groups, we have users, we have roles, and with users, so we'll start with users. You can see the explanation that is given about users is that a user is an identity with a long-term credential that is able to interact with the AWS Cloud. So you have to basically provide like a password for them to be able to interact with the AWS Cloud. For this account, I only have one user, and there are different ways you can create a user. Just go create a user, give them a name, and in this case, I'll just call them Fanumi. I think I got the name right. Yeah. Provide access to AWS management console. So this user can be able to access the account using the AWS management console. And we have different ways on how you can access AWS services. You can use the AWS management console. You can use the AWS CLI, or even the SDKs. The SDKs are the software development kits for anyone who is familiar with programming languages like Python. You can use the software development kits to access your accounts. So I just specify I want to create an IAM user, the console password, auto-generate or a custom one. I can basically provide like a custom password in this case. I hope it does not show. Let's say it has to be like 8 characters. So let me put a password. I've created a password for the user, and that's it. I can just click on click on next. Another thing, you have to add them to a group. If you don't have a group here, which is the group of admins, and if I add this user into this group, they basically assume the permissions that are in this group, which is the administrative access. So you'll be also checking on permission, or you can attach directly some bit of permissions to them, and you can see the permissions that you can always attach to them. We have administrative access. And with the permissions, when it comes to security, you have to focus on the principle of least privileges. So with the principle of least privileges, this is where you can enforce the principle of least privileges. Assign the permissions that they only need for the user. Let's say if I want them to just limit them to only one service, like Alexa for business device, I can just give them that permission only. And that's the only thing they can only do in the AWS management console once they log in. But if I give them permissions that I've assigned them, like all the permissions they need to be able to run on the AWS management console, they can do anything, whatever they need on the AWS management console with any service. So if you're creating a user and you want to limit the permissions that you're giving to them and enforcing the principle of least privileges with the permissions, this is where the policies is where you can basically let's say I have EC2, uh, EC, EC2, yeah, Amazon EC2 full access. That's the only thing they can access whenever they come to the AWS management console. So it's probably a developer, and you want to give them access to only EC2. That's the only thing you can limit them to. So I'll just add them to a group, and I'll select this group to add them to. So you can review, you can see the name, it's Fanumi, the group that they're in, which is admin, and I just create the user. So once the user is created, there's also another thing that you have to remember. If you want to access the AWS management console, we said there are three different ways. We have you can use the AWS management console, you can use the CLI, or you can use the SDKs. And if you're using the SDKs or the CLI, there is you have to use some keys, security keys. That's why you have to download a CSV file. So you can see here, we have down here, let me just highlight it for you. Down here, you can see we have download a CSV file. So if you download the CSV file, it has the security keys that you have to use whenever you're logging in using the CLI or the SDK. Something else, just a keynote you have to capture whenever you're logging in using the CLI is that be careful. You don't want to be showing off your security keys or sharing them on GitHub, because it may compromise your account. So that's it on that demo. You can just go back, then you can continue the session. So some of the services, we have the compute services that are there that you have to take a keynote of. We have Amazon EC2. EC2, basically it means Elastic Compute Service. And then we have the Amazon EC2 auto scaling. Auto scaling is basically allowing you to scale your resources, the events you're experiencing, traffics. They work in tandem. Auto scaling works in tandem with the load balancer. And the load balancer, essentially, it's there for you to distribute incoming application traffic to the different workloads that are there. You can find it probably sitting behind an EC2 instance, and you have to distribute the application traffic into an EC2 instance. We have ECS. ECS is the Elastic Container Service. if you want to run containers on AWS, it's an orchestration service. So if you're running multiple containers on AWS, you can use the EC2 ECS, which is an orchestration service for containers. Then we have Lambda. Lambda, it's an event-driven service. Basically, provision your code and then set up like a trigger whenever something happens. It's triggered and then it performs a given action. It's mostly integrated with probably can integrate it with an S3 bucket. If someone puts an object into your bucket, you get a notification. So when you integrate Lambda with an S3 bucket and even an SNS, you can get some bit of notifications from it. Auto scaling, it's basically setting up an auto scaling group in the event your applications are experiencing like high traffic. They're able to provision more instances to cater for the growing capacity. So once you go on the console, you can basically see how you can be able to create an auto scaling group from that. We've touched on EC2. EC2 basically are virtual servers that are there that you can create. To the other service that is there is the storage services. So with the storage services, we have the Amazon Simple Storage service. This one provides you with object storage. So if you're thinking of object storage, you have to think of Simple Storage service, which is abbreviated as Amazon S3. Then we have, if you're thinking of block level storage, when it comes to storage, uh, you have to think of Elastic Block Store, which is a block storage. Yeah. Then we have Elastic File System. With Elastic File System, it's whenever you have to think of file system, a shared file system that you can use on AWS, you have to think of Elastic File System. We also have the Amazon FSX. FSX basically is a file server, and they are of different types. You have for Windows, Linux, which is written as Lustre, and on NetMap with different use cases, as why you might go for a Windows file server or a Linux file server or an on NetMap. The main differences when it comes to Elastic Block Store and the file system, you realize that with Elastic Block Store, it stores mainly your data within one availability zone when it comes to Block Store. But with Elastic File System, it's a regional service and it stores your data within multiple availability zones. Yeah, I can see some questions on the chat. Is AWS Lambda serverless architecture? Yes, yeah, it is. It's implemented using the serverless architecture. So if you are thinking of coming up with a serverless architecture, you have to integrate some bit of Lambda to it. So yeah, it is. The other service, it's the database services. So with the database services, we have Amazon Relational Database Service. So if you're thinking of running relational database services on AWS, you have to mainly focus on the Amazon Relational Database Service. We'll be checking the different engines that are there if you're running a relational database service. If you're thinking of non-relational, no SQL, you have to think of Dynamo DB, um, which is also a non-relational database service on the AWS Cloud with the different use cases. Actually, most of the use cases you realize most of the customers, I'll be showing you some of the customers that actually use Dynamo DB. We have Netflix, Samsung, um, is it Snap? I think Snapchat, they use Dynamo DB. It's one of the customers that mainly use Dynamo DB. Dynamo DB, the main thing actually, it provides you with key value or document database for you. Basically, if you're thinking of a key value pair database, you have to think of Dynamo DB. It delivers you with a single digit millisecond performance at scale. Database migration. Migration is one thing. If your organization is running some workloads on on-premise and they want to migrate to the AWS cloud, you can use the database migration service to basically migrate your database services to the AWS cloud. And it supports both homogeneous and hetero heterogeneous. So anyone with an idea what homogeneous and heterogeneous is, you can also put it on the chat so that I can just know that you have an idea. So homogeneous, mainly it's the same database. If you're moving from a MySQL in on-prem to MySQL in the cloud, so you can do that migration for you. It is integrated with a schema conversion tool. So if you're doing heterogeneous migration, moving from probably an Oracle to a MySQL, it can basically do the schema conversion and basically align with the schema that you want for your database. So the different engines, the engines that runs on RDS. So we have Amazon Aurora, we have PostgreSQL, MySQL, MariaDB, Oracle database, and SQL servers. All these are engines supported by RDS. So if you're thinking of running MySQL on AWS Cloud, you can basically integrate it with RDS MySQL. You basically have to select this whenever you're doing the selections of the engines. The PostgreSQL, Aurora, Aurora is an offering by AWS. And one of the benefits that you get with using Aurora is that you realize it's 5 times faster than MySQL and 3 times faster than PostgreSQL. So if you're thinking of a database that will give you performance at scale, basically you have to opt for Amazon Aurora. We have also these other engines that you can also integrate them with. Some of the use cases of Dynamo DB, we have serverless web applications. So if you're thinking of Dynamo DB, actually Dynamo DB it's serverless since it's fully managed. You don't have to worry about managing servers or anything. The only thing you have to worry about is basically the data that you're having in there. Uh, is there any disadvantage choosing Windows AMI over Linux AMIs? There are no disadvantages. I think it's more of the use case. Why would you choose an Windows AMI or over Linux AMI? So there are no disadvantages of running a Windows or Linux AMI. I will do some demo before the session ends. We'll basically see how you can basically select the different AMIs that you want to use. You can also use it for mobile backends and most of the social media applications. And I said, is it Snap? There's this application that they basically use Dynamo DB. I'll just share a documentation on that. They make use of Dynamo DB mostly. Samsung is using Dynamo DB as one of their databases. So mobile backends, you can always integrate them as your Dynamo DB. Gamers, mostly gamers use this to get the leaderboard and the games that are there. I don't know, any games that you've played before, you can also put that on the chat so that I can see. Like I know the boys in the squad probably play FIFA in the leaderboards that are there. We have IoT, Internet of Things. You can also integrate it with Dynamo DB just for your devices. The next topic is on networking and content delivery. Just an overview of the services. We have Amazon VPC, which is a virtual private cloud. And with the virtual private cloud, I like defining it as trying to build a house. And if you're building a house, you're basically isolating yourself like from the general population. And with the virtual private cloud, it's more of like you're building a house on the AWS cloud and trying to isolate your resources from the public resources and maintaining just all that within the VPC. So it gives you that level of isolation with your resources when you're building a virtual private cloud. This is more of like your data center on the AWS cloud. So it's a private data center you're creating for yourself on the AWS cloud. I'll run you through a short demo of I think the virtual private cloud, creating one and from scratch and just having an EC2 instance in it. We have Amazon Route 53. In Route 53, it's a highly available and scalable cloud domain name web service, and it's a DNS. Actually, if you're thinking of a DNS service, DNS, sorry, yeah, a domain name system. So what mainly it does, it's convert the www.amazon.com into IP addresses. So it basically does the conversion for you. It converts this to an IP address, let's say like a 192.0.0.1 probably. So this is basically just a rough explanation of it. The reason as to why it's a DNS service, basically converting the domain names into an IP address. You know, computers basically communicate using IP addresses. That's why you have to use a DNS service like Amazon Route 53. Route 53 has a lot of features. There are different routing options that you can also make a look of when it comes to DNS. The routing policies that are there, basically if you want to integrate it with your web application. Then we have direct connect. Direct connect mainly, if you I'm giving an explanation of direct connect, it offers you a dedicated network connection from your on-premise network to the AWS cloud. So if you're thinking of transferring data, let's say you're moving your data from sorry you're moving your data from on-prem and you're moving it probably to the AWS cloud, and you want a fully dedicated network connection, you might have to opt to go for direct connect. Will I be able to get a recording of this? Actually interesting, and learning a lot. Thank you, Daryl. Thank you so much. Um, I don't know. Emanuela will provide a recording of this at the end of it. It's also, I think it will be uploaded on YouTube. She'll be able to confirm that. So if you're thinking of moving your data from on-prem to the AWS cloud and you want a dedicated network connection that does not traverse the public internet, you have to use Direct Connect, and it gives you that dedicated network connection whenever you're thinking of it. We have Cloudfront. Cloudfront is a CDN, content delivery network. So if you're thinking of a CDN, content delivery network, uh, basically you have to think of CloudFront. And CloudFront, I'll have a demo of basically demonstrating how CloudFront works. I hope the time will allow us to do all these demos that I've promised you for today's session. So with CDN, it's a content delivery network. And if you want to improve the performance of your application, let's say you have an e-commerce platform or even a website that you're running and you have your data hosted on an Amazon S3 bucket, and you have it within a given region. If you want to improve the experience of your customer base, probably in the US, you have to cache your data within that edge location. So that's why you use a CDN, a content delivery network, basically to improve the performance of your application and the experience of your users. We have a transit gateway. With a transit gateway, essentially what a transit gateway does, mainly it's allowing you to connect multiple VPCs together. And if you're connecting multiple VPCs together, you have to think of a transit gateway. You also get the ability to connect your on-premise data centers using a transit gateway and also being able to connect to other VPCs. When it comes to VPC peering, you understand it's a one-to-one connection. But if you have to use a transit gateway, it gives you the ability of more of like it's a more of a cloud hub. So you can use it to connect multiple VPCs together and just share the resources. You also get the other benefit of connecting the transit gateway with your on-premise data centers and just sharing the resources with your on-premise data centers. So we have an architecture of how a virtual private cloud looks like. This is the running on an AWS Cloud. If you can see, it's running on the AWS Cloud in this case. We have a region, and probably this is US East 1, which is North Virginia, I think. So you can see you have deployed your resources within a given availability zone. It's giving you that isolation. You can be able to access the public internet, or you can also be able to access your corporate data center and just be able to get some bit of resources from that. With this architecture, you'll realize there are a lot of things that are missing from this architecture that is here for you to be able to, for this instance that is in the public subnet, for you to be able to access the public internet. There are some things that are need to be added to the architecture for you to be able to access the public internet, let's say like an AGW, the internet gateway, uh, that is supposed to be integrated within your architecture for you to be able to access the internet. For the resources that are in the private subnet, for them to be able to access the corporate data center, you have to use like some bit of endpoints for it to be able to just access it. So this is how a VPC looks like. But we'll just run through some demos. I hope the time will not catch up with us. Um, Cloudfront, this is how Cloudfront looks like and how it's able to deliver content to the users. So you can have your Cloudfront configured with the source hub being an S3 bucket as the origin of your Cloudfront distribution. So with your S3 bucket, you can put probably your static web files here, your CSS, your index.html files. You can have them hosted within an S3 bucket, and then being able to configure a CloudFront distribution just to serve content from your S3 bucket. And that's how it works. You can see the first number one here. You can see what they're representing with number one. You basically create a bucket and have your static web files hosted there, or you can have an HTTP server. And then with number two, basically you upload your objects into your bucket. And with number three, essentially what you're doing with number three, it's now creating the CloudFront distribution from it, where you can serve your content using the CloudFront distribution. And with number four, now you're acquiring the um, this is the URL that you're able to access your web content, and it's able to cache that within the edge locations. So with the edge locations, if you checked on the AWS global infrastructure, we have the regions, we have the availability zones, we have the edge locations. So you're able to cache that within the edge locations that are there, and being able to serve your customers faster and improving the performance of your applications and the end user. So that's what CloudFront does for you. It caches your data closer to the customer. And I gave an explanation sometime back on CloudFront where it's more of if you've done streaming, the way you stream some movies, there's times you experience a lag and you wonder why. Probably it's serving you content from the origin, and probably the origin is probably in South America. And if you want to improve the experience of your end user, you basically cache that content where your customer base is. If your customer base is in China, they don't have to experience the latencies. So CloudFront actually what it does, it reduces the latency. Uh, yeah, it reduces the latencies that you have to experience whenever you're serving content to your customers. So this is an architecture of how it looks like. So let me go to the console. I promised you some demos on an EC2, creating an EC2 instance. I hope we'll do it. And an S3 bucket with a static web file. So let's go to the EC2 console. Uh, go back. So let me cancel that. Yeah, see, this is the okay. Can be seen. So I'll go to the EC2 launcher have a web server on it. My screen. Can you see my screen? It's taking time to load up. Okay. So you launch an instance. Just click on and we'll name this one. We'll name it as Top Universe. I don't know. There's a lag on my end. Top Universe. Yeah, Top Universe server. So someone asked a question on the AMIs. You can see AMIs are basically templates that contain the software configurations. And we have like a catalog, a full catalog that you can always select from it. We have Amazon Linux, macOS, Ubuntu, Windows. It all depends with the use case that you want and why are you opting to go for an Ubuntu AMI. So in this case, we'll just proceed with the Amazon Linux and Amazon Linux image, which is 2023 AMI. Um, Architecture is that we won't change anything. A T2 micro, which is a free tier eligible. Uh, just a minute as I get something. T2 micro, which is also free tier eligible. Uh, so T2 micro, there's essentially if you want to login into your EC2 instance via SSH, you have to download like a key pair configurations, ensure that you're in the default VPC. AWS provides you with a default VPC. So in the event you're launching your EC2 instance, you can basically launch it quickly and be up and running with a default VPC. Security groups, these are firewalls that basically control traffic in and out of your EC2 instances. You basically have to specify some rules. Since you're going to have like a web server on it, like an Apache web server on it, we'll have to enable HTTP traffic internet for this. If you have like an SSL certificate for your web server. You can basically enable the HTTPS, but will not be using that for now. Check on the net storage configurations and the things that you have to enable. So under advanced details, so we just scroll down, user data. So I have my user data. You're wondering what I was opening the other time because I had my like a user data that I had already pre-configured. So I'll just copy it, paste it here. So what my user data does essentially, it runs some bit of updates at boot up once we launch the instance. Then it installs HTTPD, which is the Apache web server service, then starts it and enables it. And we have to add like a bit of a comment to it for our web server, which is in the index.html, hello world from Africa. So we'll be able to see how it works. So you come here on the summary, review everything that is working fine, and then launch your instance. So within a few clicks, you already have your virtual server up and running, and you can basically run whatever workloads that you want to do on the AWS Cloud. Uh, I can see my time is almost up, but I'll just run you through this demo. So our top universe server is up and running. So let's status check. So it's running. Just a minute. Great. So I'll just click on it. Copy my public IPv4 and paste it on a different window. So you can see it works. So basically you can see, you're able to see our web server that you basically launched immediately. It's supposed to give us some bit of information to it, what you just written to it, but that's it. So we have basically launched our web server into a web using an EC2 instance, and you can see it works as fast as possible. That's how quickly you can basically deploy like an EC2 instance, a virtual server, and have it with a web server on it. So that's it. Um, the demo of launching an EC2 instance with a web server. So I'll just stop my an interesting one. It's an S3 because we have covered on S3, which is object storage. I think this will be the more to do with you, but we have this as our last demo for today. Provide you with an so you can see the different buckets, US2, Oregon, but in this case, we'll just create a bucket here for ourselves. And remember, bucket names have to be globally unique. That's one thing you have to take a keynote of with the bucket names. They have to be globally unique. If you can see, S3 is a global service, but when it comes to creating your bucket, you have to specify the region that you're creating your bucket in. So in this case, we'll say for our bucket this bucket is top universe. Top universe. Yeah, the top guys. Universe. 1, 2, 3. Yeah, I hope it has not been taken. So with the top universe bucket, what you're going to do is just have a static website on it. So top universe, the region, you specify the region. We leave everything a default when it comes to block public access. Remember, all buckets are private unless you specify that. So you have to block the public access. Um, Bucket versioning. You remember also once you enable bucket versioning, you can disable it, you can only suspend it. That's something you have to take a keynote when it comes to bucket versioning. This one is mainly for maintaining multiple variants of your objects within the bucket. Uh, that's it without terminating. I can see some questions. Will you be charged for stopping an instance? You're not charged once you stop an instance. It's only once it's running. Uh, Once it's stopped, you're not charged for it. That's it without terminating the service if it's free. Charge hourly. Guess okay. Thank you. Thank you for the questions on the chat. Then there's some bit of basically some more details when it comes to Amazon S3. If you're going deeper into understanding S3, we have encryption, server-side encryption, the things you have to take a keynote of. So we'll just create our bucket. Guys. So we upload some content into our bucket. Let me upload some bit of files into it. Add files. So we have uploaded some files to it, the index.html, some bit of images, and just click on upload. So if you have let's say your personal blog or website, basically, with a personal blog, it contains essentially some static contents, or even it's your resume, you can have it hosted on Amazon S3. And with this demo, I'll just show you how you can do it and have a static website on it. So you'll click one of the objects that you've uploaded, which is this image. Let's give it some time. So you can out the object URL, some bit of yeah, Amazon resource name, some bit of tags that are there. If I click on open, I'm able to view the object. I want to show you something here. So object, we have like an access denied. Since you remember when we were creating our bucket, we said that you have to block public access. So it means that all our content is private unless we specify that. But once I clicked on the open, this one is mainly like Amazon S3 signed URL. That's why you're able to get it. Has like a security token that allows us to view the objects that we have uploaded on our bucket, which is Mona Lisa. The Mona Lisa, they say, is the greatest art of Leonardo da Vinci. I don't know why they say it's the greatest art that is created. So we can see the image, but once you click on the URL, you get like an access denied. So we want to enable our bucket to be publicly accessible so that whenever you're using the URL, the object URL, you can also be able to view other than using the pre-signed URL. So what we'll do, go back to our bucket, which is the top universe bucket, um, under permissions. So you come to permissions. Remember we said it's block public access, but you want to edit this and allow public access. So allow public access and save changes. So let's confirm this. So we have allowed public access, but will it still be able, will we still be able to view our bucket? Still, we can't be able to view our buckets using the same URL that we used. So what you have to do is basically edit the bucket policy. And you can see we don't have a bucket policy in here. So we'll come here and just edit the bucket policy. But one thing first, I want to enable like a static website hosting because we have an index.html. So you go to properties, scroll down, where we have the static website hosting. Use the bucket to host a static website. I've said probably you have your personal blog and you want to showcase your skills in AWS. You basically put all the contents, the file contents of your website in S3 bucket. Come here, enable static website hosting. You can see it's disabled, so you have to edit it. Enable uh, hosting type, which is a static website. And the other thing is the index document. Just specify here it's the index.html. If you have an error document, you can also put it here. So in the event, let's say someone is trying to access your website and they're getting like a 503 error or 404 error, the error pages that you can always display whenever something is not working correctly. You can put it also here. So we save the changes. That's done. Want to do is edit the bucket policy to allow us to be able to view our content publicly. So we edit the bucket policy. Policy generator. You can use the policy example, which is basically a documentation that's there on how you can edit the bucket policy and all that. But for us, we'll just check on the policy generator. So under the policy generator, we select the type of policy that you want to use, which is an S3 bucket policy. The effect is allow. And here the principal will put an asterisk. Asterisk is a wildcard, which is mainly says anyone can basically view or do anything on the bucket. Amazon S3 bucket action, since we want to view the objects that are within our bucket, we'll use a get object. Where is it? Yeah, so get object as one of the actions, and then the ARN Amazon resource name. Come back to here, we copy our ARN, the bucket ARN, and paste it here. once you paste it here, you use a forward slash with an asterisk. And the reason as to why I'm using a forward slash with an asterisk, remember we said it, the action is get object, and specifying just to get the object. The asterisk is usually to specify for the resources within the bucket and the object, all the resources within the bucket. So that's it. We add the statement and generate the policy. So we'll copy this policy, close that, just go back here and paste it. So you can save the changes. So we have edited the bucket policy, where you can see it allows us the principal, an asterisk, which is a wildcard. Anyone that has permissions can view it. Action is a get object. Resource, it's everything within the bucket, all the objects within the bucket. That's why you have a forward slash with an asterisk at the end. So let's go back to our image, this one, and refresh this URL and see if we can be able to view. See, now it works. So basically that's how you do it. And if you go to our index.html, so remember we had like our index.html, our static web. Scroll down, copy this URL of our static website, and sorry, file is here. It's able to view page, which is the Mona Lisa, which says hello world. Here's Leonardo da Vinci's greatest painting. So that's it for me for today's session. It was a great time being hosted by you today, and being able to share some bit of information with you. I think thank you so much, and see you some other time. I don't know if there are any questions. Uh, the other questions that I saw in the chat, I think I was able to handle them. Hello, Amaka.
Hello, Williams. I don't know if you took this
Yeah.
question here. I just dropped it on the screen.
Okay. Where it was asking if you're charged for stopping an instance. If your instance are stopped, you're not charged for stopping your instance. So it's if in the stop state, so you're not charged for that.
So that's one like, will you be charged for stopping an instance that's without terminating it?
You won't be charged. You won't be charged without terminating it. There are no charges that you incur.
All right.
Yeah.
I think that's all the questions here. So thank you so much, William, for this session. I believe they learned a lot. Also, guys, William's LinkedIn handle is in the chat, so you can go ahead and follow Williams on LinkedIn. I think that should be fine by you, Williams.
Yeah, it's okay. Yeah. Um, invite all connections. You can connect me with me via LinkedIn. I'm not that active on Twitter, which is X nowadays, but you can always find me there too.
All right. Okay, guys, so you've heard William. So you connect with him on LinkedIn and Twitter as well. So thank you once again for coming to this class this evening. We at least we have learned a lot and we appreciate you this night. So thank you so much. Do have a lovely evening. Hope to see you some other time.
Okay, thank you so much, and I appreciate you hosting me. Bye bye. Have a great night.
All right, you too. Bye.